Morioka in Japan at ICCF-26. Yes, 26 in 25. And yeah, so in 2017, I saw something going on here in Suhas Raukal's lab. And that was a hydrodynamic vortex, many of them producing ring solitons and structures like this viewed from the side. And what this looks like is a clover leaf. It's a pattern you see all throughout nature, and it has this area down here behind it where material is sucked in. And I thought this was extraordinary. I'd done a bit of hydrodynamics when I was younger, and I wanted to explain this. It also has these two little notches that come down here. Now, in 2019, I was invited by Sho Ejiro here, Kubo. Sho.
Chill.
Yeah, and he asked me to come and test Roy Shinamaza's Amasa gas. And I came with a whole load of tests which were trying to break the paradigm of what people thought they understood about Amasa gas. And one of those things was the belief that tungsten was vaporized. I didn't really believe it. I believe something more interesting was going on with tungsten, and I brought my own welding rod with me. I know you had some welding rods, but they were kind of a bit beaten up, and I wanted a fresh one which had been clean and stuff, and we knew what it was on it. And so that's when I was introduced to Hoshi, and he was working for Mr. Amasa at the time, and he was the man that was given the job of holding the torch. And so we erected this tungsten welding rod with a bit of thorium in it on a metal bucket that we got. And we had a high-speed camera looking at it right up close and personal to the actual event. You can go and see those on the Martin Fleischmann Memorial Project's YouTube site. The experiment lasted for about 10, 20 seconds at most, and we had white fumes coming off. This was the so-called vaporization. And I had Dr. George Eagley there standing with a face mask before they became fashionable, sucking in these fumes that were coming off. And when we examined on the rod, there was transmutation in every area that was exposed to the HHO gas plasma. And inside the fibers of the face mask, there was chunks of tungsten with the same transmutation products in and around it. So from my point of view, this is an instantaneous low-energy nuclear reaction process, a fission process, or something going on. That's what I knew until I found this. And this was on the electrode, on the welding rod, and it frankly scared me. It was a bit of an ontological shock, because what you're seeing here is a vortex that's on top of another vortex, and then there's another thing down here with a spot and this wavy line, and this whole area here is like a carbon film. It's a carbon film only on one side. And over here, you've got all of the typical elements you see coming out of LENR synthesis, particularly of heavy elements. So if you put palladium in there, you put other heavy elements like tungsten in there, you see all of these elements in there rather than the ones you would expect from light element fusion. And so I've done many videos on this, but what I realized is the exact same magneto-hydrodynamic structure in this case fitted over with this round area here, perfectly fitting in this part of the structure. And this wavy line. So if we go back to the original image, what we've known from the hydrodynamics is that the from the hydrodynamics is that this is twisting this way. Okay, so if the same thing is occurring on the tungsten filament, tungsten rod rather, here, then this is twisting there. So material is being ripped off here and being deposited down there. But because it's a vortex, it gets pushed over in a wave over there. I was, I don't know, I couldn't call it panic. I couldn't call it anything other than complete shock. And I waited for Alan Goldwater, my friend and colleague, and it was analyzed on his instrument, his SEM instrument down in California. And I told him, when people understand what is on this electrode, it's going to beep, melt their brains. Beep, melt their brains. Because what was happening is the matter is falling apart. And so I wanted to find out, is that the only case? Well, in other experiments, this was on a lion experiment in the same year. On the outside of the reactor, we had a vortex and an anti-vortex with a dense part in the center and an outer part. This is 12 millimeters across. It was focused on this piece of Cantel wire, which on live video, as we disassembled this whole reactor structure, that was directly in the dead center of that. And when we look at the top there is calcium, which is not in the silicon dioxide or the aluminium oxide. So something has been grabbed from here, smashed down on there, and only on the top of that corner, you have a vortex in the calcium sulfate or calcium material crystals that are on there, and there's nothing on the underside. So that showed the flux loop. This was in line with the B field of the solenoid, but outside of the reactor. This was again outside of the core of the reactor, but it was two structures, again a Magneto-Hydrodynamic structure in line with the B field, but so the B field along the reactor was here, this was that way, okay? And in this case, it was consuming through the fused quartz, silicon dioxide, at a temperature. The maximum temperature of this reactor was 1050 degrees C. This was consuming through. It's had perfect hexagons on the back of this particular thing. It doesn't go all the way through the fused quartz. It has a flower shape, and on the back there is a flux loop that joins the two backs together. It's like a monopole and another monopole that has a material that is linking the two together, like having two pin tacks and putting a piece of string between them. That's what it looks like. So this is Neil Crichton Gold. Sadly, he passed away. This is in Amaza's vibrator plate that you managed to convince him to let me have because he said there's no cavitation going on. And step over there. He said there's no cavitation going on, and so 2 hours of argument ensued, and he finally gave me some plates, and there was cavitation spots all over it. And this is an example here. So again, the central spot of the vortex has a white area. This is different, and then there's an area in between that part and that part. Now, this is a normal hydrodynamic vortex of a ring soliton. This was done by Jeremy, Alien Scientist channel, with a laser going through it. So you can see the overall clover shape here in the form, the density going into the soliton, and the flow. And as this moves forward in this direction, it actually sucks things faster than it is traveling into its, what I call the arse. It feeds itself through its arse. And that is exactly what the water structure was doing. And so here, this is in the longest running, most energy producing reactor of Alexander Parkhomov. I was blown away, again, the clover-leaf shape with the synthesized elements in it. And this was weirdly magnetic, or responded to the electron beam. As I fired the electron beam, this would jump around. The whole cluster would jump around on the internal core of the reactor. This was, again, the Amaza gas on the 10 yen coin, right? And you had a Magneto-Hydrodynamic structure with a laser line on the non-radiating boundary, with a hole on one side and a depression on the other. And then on the substructure, you have this. So the main structure is there. This is the fractal tore down. And this is flipping over here to the third fractal level. And on here, this is all zinc in a metal coin that is only about 2.5% zinc. But this is nearly pure copper with a copper oxide layer. The spin nuclei had gone over here. This has 4.11% of its matter as zinc, which is incidentally the same amount of the percentage of the isotope that has spin in zinc. So the spin isotope had been moved over here, the zinc had been concentrated here, and on this side you had copper oxide. And then on here you had signs of long-lived plasmoids. They were moving over the crenellations, growing and consuming the oxygen on the surface and converting it to sulfur, the fusing of two oxygen atoms to sulfur. And I called this video, you can go and look at it on the Martin Fleischmann Memorial YouTube channel. It's called Snowballs on cobblestones. Snowballs on cobblestones. And that is a signature of ball lightning. That is to say that ball lightning has been known when it blows up to produce a sulfurous odor. And that is, I believe, what is going on. So that wheel was within this wheel, and that wheel was in the big wheel. This is where we start to decode the actual money shot of what's going on here. So here, again, this is the plasma structure that was formed on the tungsten rod. This is in the hydrodynamics. This is a later experiment that was developed in from 2019 in 2020. This is a magneto-hydrodynamic structure caused because of the polar nature of water being spun by a resonant standing wave node. And it forms transverse to the standing wave node, which the node is in the center. And you get a cone with a pit and a pit with a cone, exactly in the sacred geometry, yin-yang structure, okay? So that is the preface for what I'm going to show here. And it's all this guy's faults, right? So I'm not responsible. So I'm going to stand over here.
Yes.
If you could move back. Okay, so this was easy to derive. And then in my head, I had to do 3D. And I had it in my head for about 3 years before leading out. But I'm just going to run you through the specific steps that I believe is going on in this process. 1, you need a medium, and it has to have charge separation. And it can be polar fluid like water, an electrolyte, enhance its polar nature, or ion in the water, or an electron ion plasma. That is the basic start point. So charge separation of some kind. Then you need chaos. You need to get as much chaos as possible. In the medium, in the form of multi-axis hydrodynamic shear. This can be introduced in 2 principal ways. Shock. If you take your Tibetan singing bowl, you get your gamel and you smack it and it goes boom, yeah? Shock. The other way is by resonance. You go round with the gamel. That. Those are the 2 ways you get there. And in this case, in the sound case, it's phase conjugation photon or phonon standing waves. So if you look at the Cardone, you're getting phase conjugation of the phonon waves through the media. In other systems, you're getting phase conjugation of photons. So you're basically phase conjugation, you have a wave going out, either electromagnetic or sound or phonon, and then it's coming back. So it's going out like that, and then it's coming out like that. And it's got a point there and a point there. And those are the points in ultrasound experiments where you get the transverse nodes. And on the aluminium foil, that's where you get your yin-yangs forming. That happens in all of these systems. Any physical or electromagnetic configuration that can focus this chaos will enhance subsequent action. What do I mean by that? Well, the actual standing waves themselves focus the energy, but for instance, in Parkhomov's reactor, it was PNK02, Russian-made carbonyl nickel. Had lots of points. Every other way that can be done was discovered by Georgy Messias in his research on ectons. And he described that all the first time he presented in the West in 1996. And Hal Fox came up to him and said, "I'm very sorry, but Ken Shoulders had made all the patents on this." And he calls it exotic vacuum objects. Bad luck. But everything that people have been trying to do, like having silicon inclusions, like folding, like creating cracks, like creating protrusions, creating holes, creating overlays, adding different elements in, it's all in that 1996 paper of Messias. And that is talking about focusing the energy that gets produced. So order comes emergent out of vortex-driven self-organization of charge. Separate media produces charge-separated media produces at least a wheel within a wheel within a wheel. That is the minimum requirement to get a stable structure. The resultant electrodynamics produces a phase singularity at the core of every wheel within wheel within wheel fractal magneto-hydrodynamic structure. Whether it's ionic or it's a plasma or whatever, it will always create this magneto-hydrodynamic structure. The phase singularity produces a core with increasing magnetic energy. Right. What is a phase singularity? I've got things going down my plug hole. Yeah? And it's changing pitch as it's going down, so it's going And it gets down to a point where it's not going down, it's just going round. And that's like a Penrose staircase. You know, that image where you see the guys walking round and they're going round and round, but they're not going down, or they're going the other way round, they're not going up. That's a phase singularity. And this is a key property of this wheel within a wheel within a wheel electrodynamic structure. Matter goes in there, and there's several ways we can achieve this. The first way was observed by Schwerblis in 1988 in a Moscow basement, and he couldn't believe it. He saw an electrodynamic coil of a coil of a coil structure where it was producing some oscillating magnetic field at a point in space-time, and when they moved the coil and turned it off, it still existed. And when you had a coil of a coil of a coil of a coil, they claimed it lasted for 2 days. That's a very specific number. You heard me talk about that. You didn't, sorry, but you can see the video online later today. Many people have observed these structures lasting for about 2 days. Okay, so that's when they start to feed themselves. When they can get to the point of self-sustaining, where you can observe them, they tend to have enough electromagnetic energy to feed themselves. And I'll come on to why that is. So Schwerblis did not believe what he was seeing, and he went to the leading mathematician at the Russian Academy of Sciences, called Nevesky, and said, look, is there any way this is even possible? And so Nevesky took standard Maxwell equations and extended them out beyond 2 coils to 3 coils, and discovered that you get a closed pointing vector. So the energy does not dissipate. You get a closed pointing vector, and that means the energy can accumulate. And if you accumulate energy in a fixed point in time, it doesn't matter what the required magnetic strength is, you will get there sooner or later to do magic, which is where we're going to come on to next. It's basically creates a Kerr-Newman black hole, or you might call it's called a Kugelblitz, according to John Archibald Wheeler, which is a purely electromagnetic black hole. And Kugelblitz, the term that he chose for a purely electromagnetic black hole, is the German for, drumroll, ball lightning. Right? That's what the guy that was on the Manhattan Project and taught Feynman and did this whole vacuum energy story about, will boil all of the world's oceans, just the energy contained in with that. We're going to get to that point. So that's one option. The second option was published in 2008 in Sochi by a guy called Wisniewski, and he did a treatment using standard accepted equations to produce a topological monopole, which is compliant with the Dirac monopole hypothesis. And again, the electrons come down, they form Cooper pairs because they force themselves into opposite as they spin down, and then they go to a degenerate radius, which is the definition of a Kerr-Newman black hole, where you get a ring singularity of superconducting whatever. In this case, it's electrons, and that produces a continuously increasing magnetic field. The last one was David Freiberger in 2009. He was charged with trying to explain what were called cavity lights that were seen in 2001, 2002 in a national lab in the US. He was an expert in ball lightning, having been the plenary speaker at the first ball lightning conference meet in Hessdalen in Norway. In fact, in this paper in 2009, he shows one of the ball lightning, or 2 of the ball lightning images from his Hessdalen meet, from historical images of taken of ball lightning in Hessdalen. And he did the same treatment for the electrodynamics to get what he called a vacuum current. Nevesky and Schwerblis called it an electromagnetic phantom. In the case of Nevesky and Schwerblis, they said that this would allow the capture of vacuum fluctuations. That is, if you can polarize the vacuum enough over 1.022 mega electron volts to produce an electron and positron, and then they annihilate, they produce 2 511 keV photons. Those photons are immediately caught by the wheel within a wheel within a wheel within a wheel structure in the center. The mass adds up. In the case of the work of David Freiberger, he says that once you go over what he calls the diality limit, baryons lose their reference to the Dirac sea, which is an old name for the quantum foam, and they fall apart. Okay, this is in line with a statement by another scientist called John Kramer in 1983. He said if you could create sufficient magnetic strength in a monopole, it would cause baryons, that is neutrons or protons, to fall apart. So that's why everyone's been trying to look for a monopole. I've given you 3 different variations. The one by Wisniewski is quoted as a potential candidate for this magnetic monopole that is obviously there when you look at what happens by Bogdanovich et al. At the Moscow Nuclear Physics Institute to explain their long-lived luminous plasmoids. Okay, so where were we? A topological magnetic monopole is formed at these cores. It is a magnetic flux capacitor. It can store, like a normal capacitor can store electricity, it can store magnetic flux. And it doesn't stop until thresholds are reached. Vortex structures are disruptive to the vacuum state, asymmetrically lowering the vacuum energy. What do I mean? This is on monopole is in here, topological monopole. The further you get away, the depreciation of photons in the vacuum gets less depreciated. So you have a much lower pressure of the vacuum here and a much higher or normal vacuum pressure outside here. This has, I say it here, matter within the disruption zone. It's this area here, as identified by John Hutchison and as identified by Eugene Podkletnov. Eugene Podkletnov is a pulsed system that creates these structures, whereas John Hutchison is a resonant system. So you have the two things that I was talking about up here, that point two. One is a resonant, one is a pulsed system. So you have a vacuum gradient going along here when you start to get the right structure forming in here. So that lowers the vacuum energy. Matter within the disruption zone is disassembled based on the bond strengths of all types via overexcitement. So if you have a piece of matter here and you don't have one of these above, the vacuum energy is equal on all sides. So the atom itself, the normal, ordinary vacuum object, which is this structure itself, feeds from ordinary relic neutrinos, which are 1.95 Kelvin. This is the theory of Dubovik, the discoverer of the toroidal moment, Shishkins and Korols. If the atom is under-energized, it will extract a little bit from that flux of relic neutrinos. If it's over-energized, it will push that energy back into the ether. Okay? Now imagine you haven't got the same pressure on all sides, but you have a much lower vacuum energy here, and the normal vacuum energy here. What's that going to do? It's going to force feed into the arse, up the arse of every one of those atoms, and they're going to get a little bit overexcited, and they're not going to hold together very well, are they? And so you have non-thermal disruption of matter. This happens in all these systems, and I believe this is the basis of catalysis. It is the basis of the Hutchison effect and the observations of Eugene Podkletnov. So it's overexcited, which means the matter in there can't stay within the matrix. And it's not thermally melted, it just pulls up. Secondly, at this point, the vortex, as I showed you on the other images, is stretching and also depreciating the vacuum energy here. So you get a low pressure in the vacuum here, you get a high pressure here, which pushes the structure up, but you also get a really high pressure here, which condenses into a beam, and some of it, the neutral components, come out here as a high frequency gravitational wave and coherent matter. Okay, so with a sufficient magnetic strength, approximately 10 to the power 15 Tesla, bearing in mind, I don't care what the strength is, because it's going to get there, right? It's only a matter of time, right? But 10 to the 15 Tesla is what does it. Baryonic matter is disassembled into quark-gluon plasma. This is called color disconfinement of baryons. In a baryon, you have either two up, down, and then they're red, green, and blue. They have to add up to white. That's why they're called color. You could speak more about that because that's something that Jan has researched extensively at CERN. And what happens is these fall apart. Now, just like your electrons and your protons are charged particles, these are charged particles as well. So you can create a plasma and a magneto-hydrodynamic structure out of your electrons and ions, but you can also create it out of the quarks. Okay? Also, when these are pulled out, the vacuum or the process of the pulling it out with the differential here causes a creation of an antiquark. So you get mesons forming. So anyway, you get a quark-gluon plasma. So what this structure is then gets replaced not by an electron-ion plasma, but by a quark-gluon plasma. This explains all of the weirdness in LENR. All of the weirdness in LENR. Why, Jan? Why? Because it's the most superfluid thing that exists, known to man, the quark-gluon plasma. When you start spinning that, which is what you need to create the magnetic core, it doesn't stop. You can have an opinion about it. You can really, really, really want it not to stop, but it keeps on spinning. And then it feeds itself up its arse. And it does this color disconfinement. And then what does it do? It gets more spinny. More spinny. So, self-similar, wheel within wheel within wheel, electron-ion structures then produce electron-quark gluon plasma, EQGP, MHD structures. The EQHD MHD structures are stronger per unit volume than electron-ion plasma MHD structures, resulting in scales of exotic vacuum objects that have been observed experimentally. What do I mean by that? To get the magnetic strength with a electron-ion plasma, you need over a millimeter, right? With the electron quark gluon plasma, it's about 670 something nanometers, which means the overall structure of the exotic vacuum object is around about 1 micron, which, by the way, is exactly the patent of 1992 of Ken Shoulders, which in 2011, he said, 2 years before he died, that these structures are quark soup. And that's what S.V. Adamenko was seeing in his experiment. What is quark soup? It's a euphemism for quark gluon plasma. You go and look at S.V. Adamenko's book from 2007, and he says, we're producing quark gluon plasma. 2007, that they were saying in his book, Controlled Nuclear Synthesis. Ken Shoulders said it for the first time I can see in 2011. But he wasn't doing any research then, but he wanted to basically put it out there for anyone who's listening, right? So basically, you can get to 10 to the 15 Tesla with a less than 1 micron structure, which means one wheel within wheel within wheel, however many wheels it is, right? But at least 3 can, in the quark gluon plasma, maintain itself at the structure claimed by the patent holder, Ken Shoulders, okay? Those then cluster themselves. Due to the superfluidity of the electron quark MHD structure, the topological magnetic monopole is more stable, leading to sustained monopole. In my other presentation about the work of Takaaki Matsumoto, he observed structures produced in electrolysis that were binding to only iron. They are magnetic monopoles. They bind to iron. This was produced by Leonid Oretskev, an exploding wire in water. Extreme cavitation, also exploding metal. Outside of the reactor, 0.7 meters, he was collecting the monopoles, proven to be monopoles because they changed the fine constant 957, one way with the north on here and the other way with the south on there, and they lasted for, drumroll, 2 days. Right? So did the plasmoids in the long-lived luminous plasmoids of Bogdanovich moving around on the metal plate after the water flow plasma discharge. They glowed on metal for 2 days. Why? Because it's spun up enough so it can feed itself, and that's basically their lifetime with the energy that's in there when you don't actively feed them. They will run for about 2 days. This has been observed in many experiments. Heat after death is this. That's what it is. You had to have something that could live. It is living, it is consuming, and it is shitting. It is actually alive. It defined everything about life, that's what it's doing. And it's this structure in my view. I might be wrong, I've been wrong before.
It's conscious.
It's conscious as well because it has a toroidal moment. Yes. And they act together. They work together. They keep away from each other as well, you know. And unless it's better that they join together. They work as a community or they split up depending on the resources. You see it in the reactors that we run, right? So vacuum energy capture and matter disaggregation self-sustains the magnetic wheel within wheel within wheel structure. Energy is emitted from the self-sustaining structures in the form of light, leptons, coherent matter waves, and high-frequency gravitational waves. Specifically, light and leptons, the photons can be a range of energies. Up to 2 kiloelectron volts is practically observed. The photons can be typically UV or soft X-rays. The leptons are a range of energies of electrons and also non-charged leptons, as in the case of muons. And that is basically when they break, the mesons decay into electrons, photons, and neutrinos. Okay, so.
And the gravitational waves detect.
The gravitational waves is because even this structure feeds on both relic neutrinos and clusters thereof, which are called energy solitons. And the energy solitons are also pulled through here more effectively than they are with ordinary vacuum objects. And they are cohered here, but because they're fully neutral, they get fired out here, and that is the gravity. By the way, when you make a device that produces energy, it will also produce propulsion, let's put it that way. Okay, because it produces a slicing beam, like a laser, but it also does depletion here, pressure here, and feeds itself here. It's pretty amazing. It's a one size fits all for everything you want to do, as Ken Shoulders said. On dishevelment of the structures, mesons decay into light and leptons and other quanta of QGP, entering the ordinary vacuum energy level and are instantly repressurized into a range of standard, stable chemical elements based on the density of their coherent wavelets. So within the overall structure, you have some areas that have got much more of the same shit as other areas. It's all the same wave function, but as you know, the typical image of a condensate is you have a couple of bits over here and then you have a peak. Now imagine that in the overall structure, and it's fractal like this. Within the different substructures, you've got different densities of coherent matter in the quark, gluon plasma, in their hydrodynamic vortices, in that different vacuum space. When the overall structure dishevels, you get electronuclear regeneration, as observed by Takaaki Matsumoto. The matter spews out, and it hits that normal vacuum pressure of 10 to the power 113 joules per meter, and it goes and becomes new baryonic matter of a range of elements based on the vacuum, so based on the coherent density of the quark gluon plasma. Okay, so then bonds, this is the bond failure diagram, and this is the monopole here at this point, and down here we've got the base of the structure. Outside there's no electromagnetics. It's a non-radiating boundary which goes around like that. You can't see it on any of these diagrams, but I've shown it a million times, right? So at this point you have I'll go from the bottom. At this point you have van der Waals forces, around 0.1 to 10 kilojoules per mole. This is what happens, things just fall off things. You'll see this in tornadoes. Things just fall off things. Then hydrogen bonding, say polar bonding between water molecules around 10 to 40 kilojoules per mole. I have shared the pictures of a 1969 water spout, and there's a column of water coming up. That water is not being boiled. That water is having dark matter chucked into it. The energy of the atoms are getting too excited, and it's breaking those water molecules' weak polar bonds. And the water is lofting with the overall flux of dark matter. Metallic bonds. This is the Hutchison effect. This is why it's that low down on the list. It's easy to achieve because it's the next one up on the runner. But look, it's 100 to 500 kilojoules per mole. It's much, much bigger than this. You have to work a lot harder to get this to happen. But we're somewhere here. We're starting to eat metal. And literally at this point, it is where it eats the metal. Where are we? Yeah, not on these. Where have I got it? Oh, did I not include that in? Oh, here. This is the point, that point here, metallic bonds, this is copper, it's being consumed. As it goes up from that point, the area that gets consumed grows wider because the strength of the ability of the structure, of the lowering of the pressure of the vacuum is decreasing as it goes up. So there's a push going through here, over-energizing, and a pull here, effectively. So that's metallic bonds here. Ionic bonds start to happen here, but of course, remember this is all happening up here. So as this is propelling itself through things like alumina or quartz, you need 300, 600 kilojoules per mole. It's able to push its way through, fluidize those things non-thermally, and make it for. And bearing in mind, these have a structure coming out here and here. So they've got machines working on the side. And as I showed you with the Takaaki Matsumoto presentation, he saw a ball lightning with lines and also crossways cuts, which are at an angle. It's absolutely precisely what is happening, and it's been replicated by several authors. Okay, so that's ionic bonds. And in Ken Shoulders, he actually got alumina, had these things burrow through the alumina, and he had beeswax on top. It melts at 56 degrees centigrade. A thin film of alumina went under the beeswax. 100% not thermal. Okay? Then you have covalent bonds. Now, you have a resistance of carbon and silicon carbide to these structures. And this was identified over 30 years of research by one Nikola Tesla, right? And it was the only matter that could survive the bombardment of these structures made in his carbon button lamp, the only material. And that's why I recommended this carbon, silicon carbide, but specifically I said carbon and boron nitride to solve Randall Mills' problems of his, whatever he thinks it is, but it's not that, being able to do these breaking and failing of his reactors. That's because, look at this. You're up here at 1,000 kilojoules per mole. How much better is that than crummy metal bonds? This is your strongest metal bond you can have. So you've got carbon, right, in the right form, and you're talking twice as strong as the strongest metal you think you've got in the world. Doesn't matter what alloy you do, you're going to be worse. This is what you need. And then you only have no other choices. This is the only choice. So Nikola Tesla, well done. 1883, nailed it. Nailed it, right? Right, so here, the next one to go is beta isotope. Beta isotope. Ivan Filimenko, in a boiling water palladium and deuterium reactor in the 1950s, had emissions from that reactor that would affect radioactive isotopes. The emissions were neutral forms of these that were going in, and they were doing this because it's the next thing it can do. It's the next level of vacuum polarization, vacuum energy depletion that can act. You don't need to eat those atoms, you just need to let these things run through them. And what is a weak atom if it's not an atom that already wants to fall apart? A beta isotope doesn't want to be there. You know that. You don't have to debate it. A child can work it out. Thing falls apart. This doesn't fall apart. Which is the strongest thing? Oh, the thing that doesn't fall apart. Okay, so if I'm going to squash on that, I'm going to go squash on that. Which one do you think is going to fall apart? Oh, it's that one. Right, okay. So that is what's happening. That is why it remediates beta isotopes. Now, Griffin Brock has a device that I believe is chucking out a beam of these things, and we'll be able to remediate nuclear waste in situ. You'll be able to clean up Fukushima by having a band of these things and running it over the ground, beaming it into the reactor, remediating that nuclear waste in situ. You don't have to go in there, you don't have to cook it out, you don't have to put robots in that fail after 4 hours. Okay, so the next one up, and it's a lot harder, is your your alpha isotopes. 2 times 10 to the power 8, 1.2 times 10 to the 9. Show, this is the answer as to why we had more problem dealing with the alpha particles from the thorium than we did from the beta isotopes. Because it takes a hell of a lot more energy and correspondingly much more vacuum pressure reduction to remediate alpha isotopes. It'll do it, but it's a lot harder, okay? And we did this experiment with a Mars gas in a crucible, and it would appear that we knocked down the beta isotope very, very quickly. But the alpha isotopes, there seemed to be a depletion. But, I mean, it's a very rough test. You'll see it's an extremely rough test, but it looks like it does alpha, but it's much harder. There was no difference for quite a long time doing the work. Right, so then you get to the pièce de résistance, the nuclear cluster decay. Think carbon, oxygen being pulled from the nuclei. So this is Pavlos Mira's ring model of nuclei. You can go and find this at pavlosmira.cz, and this is actually his image. But he's saying that silicon, germanium, and tin all have the molecule structure, or the nuclear molecule structure of carbon. It's very similar to the ideas you're seeing over here on the simple atomic model, or whatever it is. Yeah, there. Again, the structure. And why is this important? Because most people I know, when you say, about binding energy, they say it's a big ball of nucleons. You take the binding energy, you divide it by 56 nucleons, and we find out that iron 56 has the highest binding energy per nucleon. But it isn't just a ball of nucleons, it actually has structure. So, what is the weakest part on this? Well, we already know if there's an alpha structure in there, it's got the highest binding energy. So that's not going to want to break up. So if you have a bunch of alpha particles, right, they're going to make what? Carbon? Or next one is oxygen. And that is literally what you see. Silicon converts into carbon and oxygen, which is the reverse of fusion. And it's not fusing it together, it's not fissioning it, it's falling apart. It's falling apart because the weak bit is here and here in this model. And they come off and they go, whoa, we like being together in that case. It's happening in the same process. So that is what a lot of the elements are happening in this process. So when we look at that tungsten again, this tungsten here, in this part of the vacuum, that is not fission. That is falling apart. In fact, probably most of the stuff up here, all of the typical elements you find in a palladium-deuterium reactor is the falling apart by these structures. And the next, basically carbon actually falls apart a little bit before oxygen. It's just a slightly little bit more vacuum energy depletion that you need to get oxygen than carbon. But if your structure will give up an oxygen as the most easy thing to get, you get to see what Iwamura is doing, or you get to see what this guy was doing in his Griffin-Brock electrode, which I have over here, the very physical item, because I predicted we'd have this Magneto-Hydrodynamic structure on it, and I didn't even need to put it under the SEM to physically see it. It's exactly, precisely correct. Here, I'm going to show you on here because it's clearer when it's illuminated. So, this is a Magneto-Hydrodynamic structure in a water cavitation. You can see that the material in the structure inside the vesica Pisces, inside the golden ratio line, starts here and goes up here. This is boron, no calcium. Boron crystals at the head of that part of the vortex. That is aluminium minus oxygen. Oxygen cluster has been ripped off that aluminium, okay? Then it goes around the wormhole as per the work of Takaaki Matsumoto, and it goes, this is the yang, taking matter apart. This is the yin. The yin is then, it's got a sparse spiral galaxy, just as Winston Bostick said. It's a bigger hole because it's pulling the matter in and condensing it. Very small hole, inflating. Big hole. You understand how the yin-yang works? It comes out inside the golden ratio line, inside the vesica Pisces. This is silver here. We've seen silver from calcium carbonate, and we've seen it from aluminium. We actually have coherent matter braided structures like the ones I'm going to show you in a minute down here, coming out of the side of one of these cones, blending into the aluminium, nearly pure silver coming out. But over here, coming up to this point here, we have calcium, no boron. Calcium is oxygen plus aluminium, some isotopes. So what you've got is the yin is increasing because the spin is different. It's the opposite of the yang. The yang does lowering the pressure of the physical vacuum. The yin does increasing pressure of the physical vacuum. It's freaking beautiful. Absolutely beautiful. So, let's have a look at the tungsten. If I can get out there. Oh, sorry, this is Griffin-Brock's electrode. So let me put my glasses on. This is the color electrode. Okay? This is under SEM. This is the hydrodynamics. You even have the flow of the things coming in. A very different density here, very different density here. Over here, look how it blends into this part. Absolutely perfect. Nature has one answer, just one answer. You can have an opinion about it, but it's written in your face. It's in your face. The ratio between the top of that and the center of that and the point of destruction is 1.618 on every single fractal level. The ratio between that and that and that and that, that and that is 1.618 on every fractal level. The ratio between the circle from the point of destruction here, circle to draw the outside part of this, and the next circle that defines this Sothic ratio cone is divided 1 over 1.618 on every single fractal level. This structure produces iron-rich crenellated spheres. Outside part of it is 1.618 larger iron oxide than the pure iron vitrified core in the center. Absolutely every single aspect of this structure is golden ratio. In every system you look at, and it's always the same. So I could predict this, but even I couldn't have imagined that nature would do it exactly and precisely in the process. And you know what you see in here? Have I got that? Have I got it here? Yeah. So here, you can't see it. There's two green lines, and I'm drawing between the divisions here. This has got 24 subtors on it. It's only got 2 tors at the upper level, but it's got 24 subtors in it. Okay? And it has the center. These 2 holes here are exactly and precisely where the golden ratio line intersects with the Vesica Pisces. Okay? And this is the yang side.
I wanted to say goodbye to you.
Oh, yeah, cheers, mate. Bye.
Enjoy.
Yeah, we'll do. On this side, exactly as we saw in the other one, up here, have I got it here? Yeah, here, there's a triangular core. And out of the center of the triangular core, you've got a plume of stellar synthesis elements. That is the yang side. It's disassembling matter into carbon and magnesium and so on. Okay? So, the Griffin-Brock electrode is a masterclass in this process in action. And it produces a collimated beam of energy solitons that you can do a lot of magic with. And we're going to be doing a lot of testing on that, so I'm quite excited about that. Right, so that is that electrode. It was 100% win first time. Okay, so what do we see here? This is in Benjamin Huang's cavitation reactor. Vortex, anti-vortex, with a yin and yang inside each of the yin and yangs. This is one which is broken up, and the coherent condensate inside has started to come out, and it comes out in threads. This has been observed inside the Parkhomov reactor. It's been observed inside the Lion reactors. It's been observed inside all of the work of Takaaki Matsumoto. Here you can see the tube coming out. Here is one of these tubes that's just been left on the many, many examples. So this is one type of ejection. But sometimes the internal smaller structures leave a braided structure. Here, this is all spewing out. Pure copper oxide, this is the synthesized element, the electronuclear regeneration. All of that fitted inside there. Why? Because it was coherent matter in there. All of that, this is actually a silver slug on one side and a carbon slug on the other side. This one broke open like that, and one had a yang, like I said, the silver, it synthesized silver. So it had a little slug of silver and a little loop of carbon. One is yang, one is yin. This would be the yin side, making heavier elements. This is an apple, and this is pure copper. It's a tornado of copper that's been ripped into the torus structure. That is because it's sent its beam of energy coming through, causing the matters to be loose, fluid but not molten, and it's then pulled in and it's got stuck. It got died, this structure died, and it got stuck with that bit in it. The tornado's come down, it's touched down here, and as the apple of the Magneto-Hydrodynamic structure, the tornado touched down, it was pulling stuff up, but it was also pulling itself down. And so the track gets wider as it comes down and crashes into the surface. This is beautiful because you actually see the internal structures plus all of the flow of the material around it. And the cap of that structure, it like broke there, left the other side in, and the top of it's here with the helical beam coming in here. Internal structure, 20 microns, just as Ken Shoulders said, destroying matter. Rotate that, this is the internal structure of one of those, 2 wheels within this wheel. The main part is, where is it here? Yeah. Where's the, oh, here. Where is it? Here. This had 2 wheels, and they came out here. So that wheel was made of these 2 wheels. They always come out the way they go in when this one collapses. This one had 2 wheels, and it's there and there. This is the golden ratio. So basically, it had a wheel within a wheel within a wheel. And that is the way it works. Now, this one broke up on here, and it was consuming the matter. This is a wheel within a wheel. It's consuming matter, and it's left a braided structure here, where the internal one was depositing its payload, and then this one died, and it did a helical beam coming out this way with its payload. It's freaking amazing. Here, the 2 structures crashed down and gouged out tracks. These are forms of strange radiation which we witness. And then there's one which I really like, but it's not well resolved because I didn't blow it up big enough. A pair came and crashed at this point. One went down and died here. Another one came down here and went over here. So when this stopped, this one was deflected and continued on over here. You blow that up, and the apple has got a 90 nanometer skin, like an apple peel, cut around it, which is ripped from the copper of the tube. Here, you've got two structures that have popped out. So here, the coherent matter has come out and it's instantaneously produced a new crystal of electronuclear regenerated material. So the coherent, probably quark-gluon plasma or coherent electron bare nucleus nucleon cluster has come out and immediately formed that new crystal structure there. So that is basically it. That is LENR, in my view.